Okay, I'd like to welcome everybody. Thank you for joining us for today's webinar. My name is John McMains, and I'm the CEO of Principal Technologies, and I'll be moderating and co-presenting the webinar today. Today's topic is thinking outside the on-premises data center, co-locating your hybrid cloud infrastructure at an Equinix IBX data center. So just a little bit of housekeeping before we get started. If you have any questions during the presentation, you can look off to the right in your GoToWebinar control panel, and you should see a questions pull down. And we'll be answering any typed questions directly during the presentation. So we'd love for you to participate. And we also have left some time at the end of the presentation for live questions. As well, if you look where it says handout in the GoToMeeting control panel, you'll see you're able to download the presentation for easy reference. And we'll also send you a recorded version of the webinar in a follow-up email, some contact information, et cetera. And again, we encourage you to participate and join the conversation. Okay. So first up, introduce myself again. I say John McMains, CEO at Principal Technologies, and we're a fact-based marketing company located in Research Triangle Park, North Carolina. Joining me today is Greg Adgate. Greg is Vice President of Global Partner Programs at Equinix. And as you can see from his bio, he's a technology professional up in Northern Virginia, experience in creating and leading teams, et cetera. One interesting thing about Greg is he was just listed as one of the 50 most influential channel people and CRN channel chief. So pretty cool recognition. All right, agenda-wise, we'll talk about who we are. We'll talk a little bit, Greg will talk about digital transformation, talk about our testing, the results, and perspective, Equinix perspective. All right. So Principal Technologies. So we are, like I say, we're an independent research company of about 100 people. We're located in Research Triangle Park, North Carolina. What we do is we examine and compare all sorts of data center and associated technologies in order to differentiate these technologies from others, be it competitive products or very often even comparing to old ways of doing things. And we do the studies in our lab. Our engineers actually do them right directly in our lab or in the cloud. We don't just guess at what the results will be. We'll actually do the hands-on work. And then we create a scientific paper that discusses our methodology so the readers can see exactly what we did, how we tested, and make your own conclusion. The end result is actual data about how the technologies actually perform, and not just a swag at how they might be.
I'll jump in. This is Greg Adgate. Thank you for the introduction, John. Equinix is fortunate. We're at the center of some of the most powerful digital transformation trends across all industries, all subsegments, whether it's private sector or government. And because of that position, as we help companies modernize applications and infrastructure into this new digital world, we see patterns of what they test and try and experiment with. And what inspired us to do this with Principal Technologies was to provide not just the what they should do, but why, and what are the results of doing it in this hybrid architecture that we're going to run through today. So Principal has an outstanding reputation. We work closely with them. They took over, and they're going to provide some compelling data for any company that's on that hybrid transformation journey.
As Greg said, we set out to determine how much of a difference bypassing a shared public internet connection and switching to a secure, dedicated, high-speed network connection at the Equinix IBX data center and the cloud edge could actually make. And your company devotes a lot of time and money to build an infrastructure that provides the compute power needed for your mission-critical applications. All that time is actually wasted if your data is traveling on the same crowded public highway as everybody else in the world. To use an analogy that people hear all the time is your fast car isn't going to get you to your destination any faster than the public bus right next to you. And a lot of companies will do things like get a private lane, and it may be faster because it's not congested, but it's still far away from that cloud edge. So by keeping your servers for critical applications in-house, you could actually put you at a distinct disadvantage when time's of the essence. So how do we set out to do this? So our staff set up a hybrid cloud infrastructure running a distributed e-commerce application with a backend database server residing on a technology stack consisted of privately owned resources that included virtualized compute. We actually used VMware, NetApp storage, F5, big IP networking resources. They were all connected to clients residing out in Amazon AWS EC2 public cloud. And the way we set it up, so basically a multi-tier application where a middleware is sitting out there at Amazon. And so we split that infrastructure. So our data and database is back in our private data center, and our middleware is up at Amazon. And so we compared this application, this order entry response time, and also we did file transfer speeds as well in 3 hybrid cloud connectivity scenarios to see how much of a difference it would make to bypass that shared public internet connection and switch to this secure high-speed network connection between you and your cloud provider. In this case, we went with Amazon. So I'll explain the scenarios, each one of them in more detail next. So our first scenario was the ISP shared public connection. So what we did is we actually got all the equipment into our facility in Durham, North Carolina, Research Triangle Park. And we had the typical things, a top of rack management switch, F5 big IP that was giving us our network isolation. We had a PowerEdge server in there that was hosting our VMs, including our SQL Server database VMs, as well as infrastructure VMs, Brocade switch, and NetApp storage. And so we pushed right out across the public ISP and into Amazon. And so what we were testing in this case really was the impact of that public ISP. In the next scenario, we created a dedicated NSP connection, again, from our lab in Research Triangle Park, Durham, North Carolina, excuse me, and it pushed right from there, from our lab, through this NSP connection into the Equinix IBX data center, right across the data center, through the cross connects, and into Amazon via the AWS Direct Connect Edge presence. And in this case, we use big IP for our BGP session, which is required by the AWS Direct Connect. And so, so exactly the same equipment was sitting in our data center. And really what we're testing is that private NSP connection right through that AWS Direct Connect and into Amazon in that direction. And specifically, we were at US East in Northern Virginia. In the third scenario, this is really our hero scenario. What we did is we packed up all our gear and shipped it up to Ashburn, Virginia, to the Equinix campus up there, into their Equinix IBX data center. And again, that was really the only difference, is that we took the equipment and we brought it up to the IBX data center. So now we've moved it out to the edge, and we again are using big IP for that BGP connection into Amazon AWS Direct Connect, and right into AWS. And so in this case, we're really, this was our hero scenario, that by putting it there, we are assuming that we're going to see some performance, but we didn't want to guess. We want to see exactly what kind of performance difference we would see. So here's the results. We're able to do a lot more business. So our total orders per minute, the first one is the ISP connection. The next one is an NSP connection that we did. And the green line is the Equinix AWS Direct Connect. So we're able to do 48% more orders per minute with the benchmark we ran, increasing our order processing potential by 48%. In the application latency, again, this is application, not network latency, we saw it go from 93 milliseconds, 101 milliseconds, drop down to 54 milliseconds. Again, we decreased the application wait time by up to 41%. So now looking at the actual network latency, I think this is even more interesting, is we really saw LAN-like performance by moving the gear up in that Equinix data center, not to Amazon, but actually to Equinix, again, located near Amazon, and certainly from a network point of view. And so we were seeing the network latency go 40.5 milliseconds, 48 milliseconds, dropping to 1.5 milliseconds. And there's a lot of companies that require for your database to work correctly, sub 5 millisecond response times. And so we were able to get down to 1.5, which was great. A significant difference with what we saw by, again, lifting all that equipment up and moving it close to the edge. And so the other part we did, I mentioned earlier, is we also did file transfers. So the file transfers from our VMs up into Amazon and back and forth. And this was really interesting as well, especially if you have things like, you're doing backups or moving a lot of data. We saw up to 54% upload speed, a change, twice the speed. Downloading files 86% faster. The network throughput was 7 times faster. So really significant. And really able to take advantage of the network capabilities to handle these large files, because you have a lot more control over your network. So you're really seeing a stable network connection with full frame size controls and things like that. So a huge difference here.
Thanks, John. The two scenarios there, one was the hybrid architecture that impacted the application cycles, application availability, and latency, and the data transfer put us in the position to be able to frame, well, what use cases, it's great, it moves fast. So what use cases do you apply and can benefit greatly from these architectures? And so for the data transfer story, we see quite a bit of business continuity, disaster recovery, backups, where data will get staged in Equinix and that red storage silo through a direct connect into Amazon in this case, or high performance compute, where a data lake will live in Equinix and they'll want to do a massive spin up of tens of thousands of servers to do a genome sequencing project. Was one of the use cases we've seen. This proximity and the throughput and the ability to move that much data that quickly with such low latency makes high performance compute, and then analytics being the last one, where we see more and more companies are looking for ways to extract value out of the data they collect, organize that data, and then inject that data into cloud so that they can get business intelligent decisions out of cloud through analytics scripting that lives in public cloud. And this hybrid architecture, where you park the data at the edge, have it interact with cloud, have cloud scale out massively and deliver that value back to the end user and their storage device, connected to all of the various connectivity methods on the far left, this wireless branch office, enterprise office model, really makes these use cases come alive, run better, and actually egress costs out of cloud are significantly lower in this private connectivity model. So those three are ones we see as common use cases that companies, agencies, and end users are doing inside of our data centers around the world.
Thanks, Ray. Yeah, that makes sense. It's how it would have a huge impact of those technologies. So we found that there are clear benefits to moving your gear into the Equinix data center, and you maintain your control of your hardware and really reap the benefits of having strategic parts of your IT infrastructure sitting there in the IBX data center and using Amazon Direct Connect specifically. Extending your data center right to the edge gives you that control and increase network performance and ultimately increase customer experience. So to summarize, of the 3 scenarios we tested, obviously you can see these results. Co-location delivered the biggest benefits. So moving again, your privately held components, your compute, your storage, your network, from the hybrid cloud infrastructure directly into that Equinix IBX data center provided significant improvements in application processing speed. So again, order processing speed, up to 48% better, reduced network-related wait times, 96% better, decreased application wait times, 41% better. So a lot of goodness there by moving that gear so close to the edge.
This one's a build. If you can click through, there's 4 boxes. Should have killed the build. Sorry, guys. So our role as Equinix is really We build, run, and operate these highly interconnected data centers in the right places with the right ecosystem that you can take advantage of. What we do on a daily basis is have conversations with IT decision makers and business decision makers about how to modernize their current architecture. And these 4 use cases are the most common we see around optimizing the network, connecting to hybrid cloud and building hybrid multi-cloud architectures, using that architecture at the edge to distribute security and distribute data. So in the proof of concept we did here, we did a combination of all, primarily the network optimization, where you saw we attacked latency by moving physical assets to the edge and literally eliminating latency. Then connecting privately to Amazon and scaling the proof of concept into Amazon over a private link, and then parking the database and the storage at the edge so that the web app on the front end could interact with the database that lived in the physical asset and the storage and this scalable, highly transactional model. So what we've proven with the proof of concept is our what scenario, what should you do, this slide, is actually backed up by why, the performance gains that you get. So this is what's candidly fun about what we do at Equinix, is having these conversations about what's possible. Go to the next slide. And it's not across one industry or segment or subsegment. The interconnection that drives the value that we've talked about here, that private connectivity into digital platforms at the edge, is growing in every sector. It's growing with our network providers, financial services ecosystem, content and digital media firms, enterprises that are connecting to supply chain, and then cloud and IT service providers. Is a massive area of growth for them, because as they try to win more enterprise production workloads, connecting privately and minimizing the round trip delay and latency from the cloud back into backend systems unlocks more value for them and drives their consumption meter more so than over the public internet. So let's go to the next one real quick. So stepping back, what we did was Ashburn, Virginia. Where we did it was a Raleigh, North Carolina, Durham, North Carolina, to Ashburn, Virginia scenario, because we wanted to replicate a common migration plan and path that a general enterprise would go through. What's great is these red dots around the planet are where Equinix has our Cloud Exchange fabric, where companies can come in, partners and users and agencies can come in, connect to the fabric, connect to clouds and digital platforms in this private model. And so the ability to connect to your choice of clouds, in some cases multi-cloud, and run and gain the performance gains that we talked about and proven in the proof of concept, it's really repeatable. So these global companies we work with who start in Ashburn, move to Silicon Valley, extend to London, establish a footprint in Singapore and Sydney, you take the same runbook and you take the same architecture, and you end up with this really repeatable, scalable, global platform that drives the same kind of value that the Principal Technologies team proved out in their performance testing with us. So it's an exciting thing that we get to deliver, and conversations we get to have about modernization of legacy infrastructure and applications, and educate what's possible. And then now, thanks to Principal Technologies' work, we have proof points of the actual performance benefits you gain by leveraging this architecture. And so, small plug for Principal Technology, fantastic to work with. Definitely grab their data off of this webinar and talk through with them how they can help you as you're testing this type of hybrid architecture.
Yeah, thanks, Greg. It really is interesting what a footprint you guys have all around the world, because a lot of testing we've done for a lot of companies, getting down to the small number of milliseconds from wherever your data is sitting into those cloud providers. And we of course tested with AWS, but as the list here, Azure and Google Cloud, Oracle Cloud, IBM Cloud, we can't guarantee, but we would expect to see similar results. Those kind of providers. All right, so we have some time for questions. If anybody has any questions, they can type them in, and we'll be glad to, either Greg or I can jump in on them. So somebody asked the question, what was the ISP connection used for the shared public connection to the internet? So both the shared public connection to the internet, the ISP and the NSP connections were 1 gig fiber connections. And the other question was here, why was the latency higher on the private connection? So if you remember back in the slide, we showed the ISP connection, and the NSP had a little bit more latency on it in a couple of the scenarios. And it, really, even though it's a private connection with a dedicated bandwidth, we still don't have control over how many devices are in the path, the distance, or the direction the path takes. So we have a little less control. It's dedicated, but some of those other parameters, like how many devices, those parameters fall in control of the network service provider. And our ISP connection is pretty solid here as well.
I have a question about, is the use case where you have a web app living in cloud and then private infrastructure where the web app is talking to the private infrastructure, is that a common use case that happens inside of Equinix? And the answer is yes. The companies that we work with, both partners and end users we work with, are really smart, and they're figuring out ways to use massively scalable cloud resources and auto provisioning, but also without having to do extremely expensive rewrites of existing infrastructure. So the ability to take a web-facing app and have it talk to an existing database that's been tuned over time and not have to rewrite and re-provision that database, but still get the scale on the front end, so the user experience is excellent and that the app performs better, is a very common use case for us, and an exciting one as we're trying to help accelerate modernization and digital adoption. And then one other one I had there was, are there any cost or time to market advantages to interconnecting to clouds inside of Equinix? The time to market is, yes, we're physically in the same building as the cloud edge and as the network edge. And so we run cross connects, fiber cross connects, if you want to take a fiber cross connect, inside of 72 hours. And if you escalate with your account team, even faster. If you're connected into our fabric, you have a port that's in the fabric. It's all software defined provisioning. So you can literally spin up and spin down virtual connections to cloud destinations on the fly. So way faster than provisioning local access and dragging a connection out to an off-prem location. And the cost, the TCO element of it, not even counting the time you save, the actual egress charges of data coming out of cloud as it is producing an analytics workload or delivering data back to a backend database is significantly less expensive when connected over the cloud provider's private connectivity option, like Direct Connect for Amazon. There's financial advantages that they price into their service for using that service.
All right, and another question we have here is, what were the size of the files used for the file transfer tests? And they were, for both upload and download, we used 5 gigabyte HD video files. And again, they were coming across the 1 gig fiber internet connection. And another question, actually, I think this is more for Greg, but physically, how far is the Amazon facility from the IBX data center? That one, Greg?
The Amazon East region is actually not one place. Most cloud providers have multiple campuses, and then they interconnect them, and Amazon's very advanced in that regard. But it's down the street. The reason why the latency is 1.5 milliseconds is it's down the street, and again, they've brought their own fiber into Equinix, established their own product offering called Direct Connect, and also fibered into our Equinix Cloud Exchange Fabric offer. to be able to then jump on their private fiber back to their east region. And so when the recommendation we make, and you referenced it earlier, John, different cloud providers in different cities, you really want to look at where are they and how far are they, and do some testing of your application, because physics is in play, and the closer you are, the faster it goes. And so you want to make sure that you understand what those performance characteristics are by city. I see one that's here that says, you mentioned multi-cloud. Can you elaborate on options? So I'll take that one. Sure. Because our private connectivity options, there was a picture of the map, and it had all the cloud provider names underneath it. Essentially, what we've done is create ecosystems in the 33 cities where we have our fabric, our service offering called Cloud Exchange Fabric. On the front end of that fabric is a customer connection or a partner connection, buying a port. Through that fabric, over private fiber, is routing to any one of those cloud providers that was mentioned. So we had Amazon, we had Microsoft, Oracle, IBM, Google. There are also SaaS providers like ServiceNow and Salesforce, where you can actually peer at layer 3 with them in a private peering model. So that multi-cloud concept is you have a one-to-many set of options in the same physical location, aggregation point, in these Equinix data centers around the world. And each of the data centers have multiple cloud on-ramp options in them. And that's where our teams will help you understand, depending on the city you're in and where you want to be serviced, which cloud providers are connected where. And for most of the large ones, most of the large hyperscalers are in most of our data centers and can connect to them in each one of them.
Yeah, that's amazing. Another question, I'm with a global company headquartered in Singapore with data centers in New York, Munich, and Brazil, with apps running in multiple clouds. Will I see the same transfer results? If not, how can PT and Equinix support me to get these test results? And can you help with migrating, connecting data, running multiple apps? From a PT side, of course, for one thing, actual results certainly will vary, especially determine physical wire distances between facilities. But it's definitely something that PT can help with, to do these kinds of tests to figure out exactly the kind of performance you would see. Maybe Greg, you could take the Equinix side of that.
Absolutely. Equinix has a number of resources available to help from our pro services team that will actually help identify what apps can move and how to move them, to our solutions architects who will allow you to look at how you assemble the Lego building blocks and in which cities. And then we have an inventory by city of, you mentioned Singapore in that question. Singapore is densely interconnected and has cloud on-ramps to most of the cloud providers in Singapore. And so if you've been to Singapore, you know it's a fairly small country, island. And so the latency is they're all very good from Equinix into those providers. Australia, if you're trying to connect from Australia to Singapore, different ballgame, very long way. And the latency is not great between Sydney and Singapore. But the good news is most cloud providers have built local presence both in Sydney and in Melbourne in Australia, and we happen to have cloud on-ramps in both Sydney and Melbourne, interconnecting and scaling into those resources. So to say it in fewer words, we're here to help you figure out who's available where and what some of the considerations you should be making when you're looking at multi-country, multi-cloud deployments.
Any other questions?
Yeah, there's one that is I like this one because it really starts at the heart of things. How do you typically start the conversation about hybrid cloud? At Equinix, what we do is first we listen. What are you trying to accomplish? What mission as an agency or what project as an enterprise are you trying to achieve? In some cases, it's a workload. a specific application that's end of life, or a set of technology that is not being supported anymore. So they have to move. In other cases, it's big picture. They want to shut down a building and consolidate those platforms and applications and move them out of a physical location so they can sell the land. And they've gone, with a cloud first strategy. So that doesn't happen overnight. That's a phased migration and set of methodologies that starts with knowing what you have, knowing what can move, what needs to be written, and what you park at the edge for transformation. So our first question is what are you trying to accomplish? And then typically we end up with conversations on here's a first step to take you on the journey. And I had a slide that had network optimization, multi-cloud, distributed security, distributed data as 4 use cases. We'll run them through those 4 use cases and how sequencing of those 4 use cases can help them on that hybrid cloud journey. First, shortening the distance to the edge, then interconnecting to hybrid, and then deciding what you want to put at the edge, whether it's your security policy enforcement or your data, so that can interact, as we talked about in the analytics and high performance compute use cases. But that's typically how we started, is really listening and then coming in with these observations on common use cases that happen in our sites. There's a rarely, it is an AWS specific one. AWS launched VMware on AWS sometime back. They announced it last year. Would the private AWS direct connectivity at Equinix benefit this kind of hybrid architecture? Absolutely. Private connectivity from, if you're running VMs on-prem and you want to migrate those VMs or scale those VMs into VMware on AWS, that private direct connect model from on-prem to public cloud applies to the VMware as well. And certainly parking the private cloud assets at the edge in Equinix and then connecting through Direct Connect or through our ECX fabric into AWS running VMware, that also has big benefits. One of them makes it easier to migrate, just the private connectivity model. The proximity model of parking that private cloud to make it hybrid at the edge inside of Equinix then gives you the lower latency, higher throughput and performance piece than we did in this testing, trying to use the public internet across distance. But it absolutely applies to VMware on AWS.
Okay, I think that's all the questions. A couple of things I did want to mention. When I was talking, I mentioned the scientific papers that we create, and in the PowerPoint deck that is available by clicking on handouts on the right-hand side of the GoToWebinar control panel, you can download the PowerPoint. And in there are links to the actual reports and the actual testing that we did that you can see. And we'll also send a follow-up email, as I mentioned, so that you can actually get the recorded portion of the webinar as well as all these handouts. And I think that, do we have one more question? One more question just came in.
Does Equinix provide any tools for managing the private and public cloud? Good question. Are we in the business of providing any orchestration tools, I think is where this one's going, as opposed to the portal or APIs we provide into our fabric. Our fabric, which has the multi-cloud, which is the multi-cloud on-ramp, there are APIs that you can connect into, or you can use a portal to do your provisioning. But in front of that switch, are we providing any software to say, I want this workload to land in that cloud? We do not. Our partner community does that, and end users, their own IT staffs do that. They make the selection of the front end orchestration tool and platform. We just make sure that they can connect to it and do the provisioning from where that orchestration platform lives through our switch and into their cloud of choice or clouds of choice.
Okay, I think that is the last question. This page here is the some sources, and again, off to the right, you see the links to the Principal Technologies reports that we did, and also we'll make sure we have contacts sent out to you as well in the email, so you'll know how to get in touch with either one of us, and Twitter information, etc. So really appreciate Greg. Thanks for joining me today, and appreciate everybody jumping on the webinar. Have a good day.
Thank you, John.